Okay, so let's visit the first person template map that we used to do in one of the previous tutorials, and let's see what were we up to here. We got this guy. So on begin play we're doing some stuff, starting with third person camera, and then we have two events. Okay, weapon pose, weapon absolute pose. Okay, so you got three animation poses that we set up. We change animation poses on the change of first person, and on C we toggle first person, and on V we just toggle camera without changing any settings. So on C we are going into first person, and then our animation master component, it has an event dispatcher, and this event dispatcher is telling us that we switch to first person, and then we can do stuff based on that switch. Okay, so C and V, let's test those. So on C we switch to first person, and we have those additive animations to first person hands, and we can see that the gun is sticking to the animation very well. We have no frame tearing, we have no mid-stepping update issues with the animations because of how the anim graph is being set up. So this is a proper first person experience. Let's see how it looks like in multiplayer and from third person perspective. So the aim offset is not bad. Of course we don't have turn in place animations, so that's why this is awkward. Swaying is fine. There's quite a big sway, but that's actually due to camera lag settings. This camera doesn't have lag at all. Okay. And I think we turned off motion blur for the entire project. That's why we don't have everything blurred out. Okay, so that works. I disabled auto aim because I was using this example for auto aim. So how it was working, it was on event tick, it was doing a camera trace, and if an object had tag can be target, it was starting aim assist as long as we are aiming at the target. So as long so when we move our mouse away from the target with enough strength, it just was losing the target. So just add maybe to this tag, and what's the tag called? Can be target. Okay, so let's just add tag can be target. Okay, save. Now we are doing auto aim, and if I move mouse button, it's being pulled back to the center of this actor. So it is auto aiming, but it's not, it doesn't have much strength. I can still move my mouse around. When I stop moving my mouse, it's getting pulled over, and it's fighting with me to pull over to the middle of this cube. But if I move it away from the cube, I break from this bond of auto aiming. But if I aim at it even by mistake, I will start auto aiming again. So this is the auto aim settings. We will not play with that right now. We don't need that feature here because we will focus on something else. This entire character is set up in such a way that we have a gun already attached to the body on the hand air socket with some offset, with very small offset, and yeah, that's it. That's just a mesh attached to our character, and all the logic for this gun, if we would have any logic, would be inside this character itself. But what we're going to do right now, we're going to set up a new actor that is a weapon, and we'll be able to attach it to our character, and we will make it shoot with a plugin called Easy Ballistics. So let's start. Let's go to our examples, blueprints. We can start over here, and we'll make a blueprint which is an actor, and we'll call it BP example gun. Okay, and BP example gun, in its root it will have a component which is a skeletal mesh component, and weapon mesh, and this mesh will be the example gun, so skfp gun, and we'll make it default root. So thanks to making it root, now we can simulate physics on the entire actor, and it will just take the root component and simulate physics on it, so we can drop this weapon, for example. We're not using any animation on this weapon, at least not for now. And what else do we need? Oh yeah, we need to make sure that in our plugins we have Easy Ballistics turned on. It is on, that's amazing. And we will need EB Barrel. So EB Barrel is a weapon barrel component, and it contains all the settings that we need to make a weapon. And it also has an attachment point and rotation. So let's first of all, let's check our mesh if it got any sockets. And it doesn't look like it. Let's look at the skeleton. Oh yeah, it does get. So we got a muzzle and we got grip point. Okay, that's amazing. Okay. Okay, so we got this and we got muzzle. So let's copy the name of this. Copy. And we go here and we'll check out, oh okay, we can just check out attachment point and do it muzzle, and it's also taking the rotation from the socket, so we have the rotation properly set already, so this will spawn our bullets. Okay, compile, save. We got a base weapon. Now let's go through all the settings of the EB barrel and let's use some of them. So debug arrow size, this is an obvious one. We don't need it to be so enormously big. Inherit velocity. Inherit velocity means that the bullets that we are shooting from this actor are inheriting initial velocity from the actor itself. Now, why would you want to add velocity of the actor to the velocity of the bullets? The bullets usually have velocity in tens of thousands of units per second, while the actor moves at maybe hundreds of units per second, so 1/100 of that time. And this velocity shouldn't change anything, but actually it does. If you have a simulation game where you have, I don't know, guns mounted on cars, or for example game like World of Warplanes where you have planes going at subsonic speeds shooting at each other, then adding velocity is very important. Recoil multiplier will also leave it at 1. Additional initial velocity, we can add velocity for example based on wind or something like that, but there is a wind model anyway. But we might have, I don't know, gravity pulling bullets to a side or something like that. We could just make some way of, you know, shooting around a corner or something that would change the velocity of the initial bullets. Okay, spread. Spread is, I think it has a description. No, okay, so this is how much random spread is being added in units per 100 units. So if I add 1, that means that on a range of 1 meter I will have a spread of bullets of around 1 centimeter. But on 10 meters it will be 10 centimeters, and on 100 meters that would be 1 meter spread. We'll test this setting and I will show you a few cases of how it's working out. Okay, we can have a certain variation to muzzle velocity of bullets. So we could go like 1.95 to 1.05, and whatever velocity of the bullets that we have, it will be multiplied by this value. We can also have a fire rate that is random or fixed. So let's say that we're doing an machine gun that will, well, most guns, like actual guns like AK-47, they shoot up to 10 rounds per second. So a full magazine out of AK-47 is just 3 seconds. Submachine guns and sub pistols like Uzi, they shoot even faster. But it will be hard to test some of the functionality, so let's say that our fire rate is 5 bullets per second. Okay, so those values are how many bullets it can project per second. Fire mode, you can pick any fire mode. So full auto means that if you hold on trigger, it will continue shooting with this fire rate as fast as it can until it empties its magazine. Semi-auto means that you have to let go of the trigger on each fire, but you don't have to do any other action in between the shots. Burst means that it will work like full auto, however it will, well, shoot in bursts, and you can see how many bursts you have before it switches to semi-auto basically. Interruptible burst is same as burst, however you can stop the burst by letting go of the trigger, and this is the most realistic way of shooting when it comes down to real burst weapons like in real life. Manual means that it requires you to ready the weapon after each shot. You have a special function for that. So that would work, for example, for very old black powder revolvers. That would be something you would do for, I don't know, weapons that are bolt action, for example. You would have to bolt the next bullet before you can shoot again. So you have to do one extra action that can be automated, ability based, animation based, but you have to do something before you can shoot again. Slam fire. What was slam fire? Oh my god. I don't recall this way. I think this is specifically done for weapons that are single bullet, but I need to check out what that is. And Gatling means that a weapon requires a certain pre-time to speed up the barrels before it can start shooting, and you have this Gatling spooling that can be automatic on trigger hold, or it can be manual. So for example, you would hold right mouse button to spin the barrels and then left mouse button to shoot. But for now, let's leave it at full auto. Now, shooting blocked is exactly what you might expect. So it means that you cannot shoot weapons. So for this blueprint itself, we're going to make a variable, which will be called you know what? We don't need a variable. We're going to make an event. We don't need any of those. And let's go and do a custom event. And we'll do block shooting. We don't need a variable because we already have variable, and all we need to do is just set it can shoot, set shooting blocked. Okay, and this is a replicated variable, so it means that it can be set only on the server. We don't have to do it like run on server or something like that, because that event would be used automatically by whatever core functionalities we have in our character. I will show you what I mean by that. So this is blocking shooting. Okay. Because we want to block shooting, for example, when we're just walking with the gun, not aiming, not in first person mode, not in combat, and we don't want to be able to shoot a gun that we have reference in the character, but for example is holstered on our back. And if we don't block shooting, we might be able to shoot it from our back. Okay, then component tick, let's leave it on. Let's not peg this tick rate to anything. Okay, now cycle ammo unlimited. That means that right now we are using one ammo type and we have unlimited amount of this ammo at our magazine. And we need to specify ammunition, and ammunition is being specified by class, not by objects. So let's make ammunition. Let's go to AGR examples. Blueprints, and let's go here and make a blueprint class, and it is a special class called EB Bullet, and this is an actor that is not based on a projectile, which is quite interesting, but it's a specially prepared projectile. So let's make this one. Let's call it BP test. Oh my god, BP test projectile. Thank you, autosave. Okay, and inside this projectile we got just a default scene root, and we will not add any mesh or anything to it yet. We don't really need it. All we need is what we have here in our class defaults. So in our class defaults, we got debug enabled, yes, because we want to see our bullets and we want to be able to debug them. Debug trail width will be just 1, and time will be, let's say, 3 seconds. No, we don't need that. And there is a wind current efficiency that we can set on spawn. So there's a few functions we can override. So let's look at those functions. Those are all actor functions, so nothing amazing right here. But we have some EB bullet functions. So we got collision filter. Okay, so this is taking a hit result on a hit of this bullet, and then we can, well, break this collision and, for example, say that we want to, ignore some actors that specify some values. This is one way to do it. Then we have get air density. We don't have to do anything about that. It's from the class defaults. Speed of sounds, it's from class defaults. Wind, okay, get wind. Word object reference and location. And this returns a vector. Okay, so this is setting up the wind vector, so this one. Okay, and then there is on impact. This will be a very important function. On predicted impact, so we can do some predictions. On trace is basically tick when the bullet is tracing. How is it tracing? I will tell you in a bit. On trajectory updates received, this is a post-traced event that's happening when you are actually moving the bullet from one point to another. So in Unreal Engine you don't really have, I mean, you have for the base projectile substepping, which means that if your frame drops below certain point and you have a moving object, and this object moves so fast and the frame rate is so low that this object on one frame is here and on the next frame is here, it might not register a collision. So substepping is getting a point A and point B and projecting line trace or projection between those points on an arc, angle, or a line, and seeing if maybe the simulation missed something on the way, and when it does hit something, you do a trace from both ends, so you know how wide the object is, where did it start, when did it end, and you have all those events that are connected to it. But the only real event that we have to do is event on impact. Okay, so we're just doing this, and we're not doing anything with this, and we're going back to class settings. Okay, so okay, let's say that we have an Earth atmosphere. Sea level air density, we leave everything as is. Sea level speed of sound, this is the actual word speed of sound. Air density curve, we can have a okay, there is no example curve, but you can make a custom curve for that. I think that there is an air density curve on Ballistics FX project, so we could use it right here. You can change the speed of sound with altitude, which is a real thing actually, because with altitude the density of the air, the pressure is being changed, and as the pressure changes, the speed of sound changes as well. And you can have a curve for that. Word scale, this is same pressure at sea level, so it's doing a full physical simulation of how projectiles act, because the projectile has the worst telemetry where it's nearby the speed of sound. When it's moving faster than the sound, it actually has great telemetry, and when it's moving slower, it's got okay telemetry. But there is this very important point that means that the projectile doesn't slow down linear. It slows down based on how close it is to the speed of sound. We'll set delay to 1 just as it is. If we have to adjust it, we will. We can do a custom save large ignore actors. So we could have an event on spawn, or we could have some variables that you would set up. So for example, I would have an ignore list, and this is a list of actors. Let's just do it. Okay, so we got this list of actors. Now, if we expose this list of actors on spawn, when we are spawning a bullet, we could write this list of actors. And then on begin play, we can set ignore, collision ignored actors, and we can set this ignore list to it. But we don't have to do that because the only thing that we need to actually ignore is the owner and the weapon itself. So it's fine right now. Shotgun. Shotgun means that you're shooting multiple bullets at the same time. And it's adding a random extra additional spread to each of those bullets so they don't spawn in one line. The other way to use this shotgun setting is that if you have a Gatling gun, for example, you would have to spawn to do a realistic Gatling gun over 200 bullets per second. If you try to spawn 200 projectiles that are doing traces per second and try to do it for a few seconds, you would maybe even crash the engine and definitely greatly decrease your frame rate. So you don't want to do it. So instead of spawning 200 bullets per second, it would spawn, for example, 10 bullets per second, but making a shotgun of 20, and that's a lot lighter event. You still have a lot of projectiles, but you don't have to do this entire complex loop of spawning them. Okay, flight. Muzzle velocity, minimum, maximum. Okay, that's crazy. Let's make it something more realistic, like 43,000 and 44,000, for example. Okay, so that's actually a quite slow projectile. Actual projectiles of 9mm submachine guns or rifles would be something around 730. Yeah, let's make it realistic. So 730, 760. Okay, spread. So this spread and spread from the gun are being not multiplied but by added. So we might have different projectile classes. One projectile class for example, extremely accurate bullets that would have better stats, and we could have another bullet that would deal very high damage but is not as precise or move slower, or we could have armor piercing rounds that have also same velocity but different damage, different mass, different everything. Now we also have a mass of a bullet and its diameter. The diameter doesn't really matter that much to I mean, it does matter for how it is decelerating. So the bigger the bullet is, the bigger the drag of that bullet. But mass, yeah, it also affects obviously how it slows down in air, but we can also read those values, and on hit we could get, for example, the velocity of the bullet, and we can multiply it by mass to get momentum, and momentum is basically strength of the impact when something is forced to a stop on impact. So we'll work with that in a second, and we'll actually deal some damage with those bullets. But let's go back here. Okay, so we are here, flight, this is realistic, spread. To the bullet we'll leave it at 0. Mass, diameter, we'll leave it as is. 556, so this is a M16 bullet. Form factor, this is, I think, multiplication of those values, so we'll leave it at 1. Mach drag curve, So this is like a multiplication of a chance that an angle will be changed on impact. If you have armor piercing bullets, you have a bigger chance that on impact, if the bullet penetrates, it will go in a straight line. But if you have hollow point bullets, there is a very high chance that the bullet will come at a completely different angle than it entered. So whenever it passes through, it will pass at a different angle. It might be the same as entry, but it might be absolutely different. So this is a coefficient for that. Minimum penetration, max penetration is the depth of the penetration, and this can be multiplied by a lot of things. So let's leave it at minimum penetration 10, maximum 20. Okay, so that's fine. Penetration normalization. So this is probably how much chance of penetration you have depending on if you are close to this edge or this edge of the value. Grazing, so that's the multiplication of how far did you penetrate times this one times the standard one. Okay, penetration entry angle spread. So this is a random spread to angle. Exit, additional random spread. Let's leave it at 0.1 because you never have a ideal clear penetration of just straight line. You don't see that often in real life. Ricochet probability, this is the base probability that can be multiplied by different values. Let's leave it at 0.1, but you can specify then later this per physics surface. So let's go further. Grazing probability is just 1 because that's a base value. Restitution, I'm not sure what this does. Okay, friction, so this is how much ricochets can slow down the shot itself. I don't think 0 is the correct value, but let's leave it as this for testing purposes. Ricochet spread, let's leave it at 0.1 as well, because ricochets never go at a perfect angle, but it will be pretty close. Speed controls ricochet probability. Okay, that's cool. So the faster the bullet goes, the bigger the chance of a ricochet probably. Add impulse, which means that you add force to your bullets. Impulse multiplier. So the impulse is being calculated by the mass and velocity, and you can then multiply it by a value. So the projectile in the first person example project, where you have this orange ball that is bouncing around and it's moving all those boxes. Each of these boxes has a mass of 400 kilograms. Okay, so and this box got a mass of 2 tons. It simulates physics, but it's a 2-ton box. So a small bullet that weighs just few grams couldn't possibly move this. That's why the mass of the projectile that we are shooting, the orange ball, is in hundreds of kilograms. So if you want those projectiles to move those boxes, you would just set this impulse multiplication to like 400 and that would do the trick, but we'll leave it at 1. We want penetration and we want ricochets. We don't want to just apply physics to stuff. Okay, default penetration trace type by component, double-sided geometry, backtrace. Okay, so double-sided geometry means that it requires double-sided geometry and it requires a penetration hit from both sides to do penetration. By components means that if the projectile hits something, it will test this component that it got hit on penetration on the, so it will do a trace on the other side of the object. But if an actor is made out of, multiple very complex components, that could be an issue. So if you have a destructible, that each destructible is made out of components, and those destructible components are separate components inside the actor. So if you put it here and you say by component, that would mean that if you hit a box that is destructible, it would not test the entire destructible box as an actor or as a just trace of hits. It would test this one component and then do an exit, and then it would hit another component and do the same test and then exit and another component. So what we will set here, it will be double-sided geometry. So we are just testing for any object that is closed, like those walls, like those boxes, like basically anything we have here, and it will that it won't mind how complex it is. It will just check on the other side. So we'll leave it at this. Material response time, there is none here, so we will, I think, make one maybe. Why not? It should be, instead of data table, it's just a data asset. Okay. EB, yeah, it's here. Oh. Okay, so this will be data asset base bullet. Okay. And what do we have here? We have, wow, okay. Ah, okay, so this is a map of physical materials that got all this extra stuff applied to it. So this cube, oh yeah, we can overwrite. So let's say that we use PM concrete on most of it. So all walls, big walls and floor, they're all concrete. And let's say that all cubes or editor cubes, doesn't matter how big or small, they will use PM stone. Okay, so we got two materials, stone and concrete. Okay, so let's go here and we'll do PM stone. Okay, and for stone we want to do oh wow, we can override the penetration tape type. So let's do double-sided geometry. Oh, we can do never penetrate, that's cool. Penetration depth multiplication. So if it is soft like wood, we could for example do 2 and make it penetrate harder, but because it is stone, we'll actually make it 0.5 or even 0.2. So it will be a lot harder to penetrate. And then we have penetration normalization. Okay, normalization grazing. So this is also probably additive, not multiplication. So we're leaving it as is. So the default value for the bullet was 0101. Entry angle spread. No. Penetration exit angle spread. No, we're not moving those. Never ricochet. Definitely not. Ricochet probability on a stone. Twice as high. Resist duration, influence, friction, influence, spread. Okay, we'll leave it as is. So we got stone, and stone is hard to penetrate and very ricochet friendly. And now we will have concrete. Actually, we have at least one more that would be just wood or oh, there are some engine, but I don't want to mess with them. Grass, ground, stone, water. Okay, you know what? We're going to go here and we're going to make a new one that will be called wood. And this wood one will be... ah, damn it, we need to make a surface. So it's going to project settings. Surface and wood. Okay, we got wood and we can now pick wood. Okay, save, and we got physical material wood and it is wood. Surface type. Okay, we'll leave at this. Concrete. Concrete will be also harder to penetrate but not as hard, so 0.5. It will also do I don't know what, backtrace. This is the default setting and it's okay. We'll leave it as is. We'll leave it as is. Never ricochet, no. But probability of ricochet on a concrete will be lower. It will be 0.6. just to show the difference. And ricochet spread, and ricochet spread on this will be 0.2. It will be higher. Okay, and now we have wood. Wood will be soft, penetration depth multiplication will be 2, and it can ricochet actually, but it has a small chance of ricochet, so let's say 0.2. And friction spread, and it will have a high spread, let's say 0.5. Situation, okay, it will be 0.5, friction 0.5. Okay, we'll leave it as is. So we got 3 materials that will alter our settings in our bullet. So let's go back to our bullet, and let's go here, and let's set this table to DA base bullet. And we can have multiple tables for different types of projectiles, and we can you know, hard code them into the projectile itself, or we can change them on the fly. Okay, material density controls penetration depth. Okay, so it's taking this, I guess. Material restriction controls ricochet. Does it have... This is the friction. Surface type. Okay, so this is density. We haven't changed it for any of the physical materials because actually most people don't change any settings when it comes down to physical materials, but physical materials apply to almost everything when it comes down to Unreal Engine. So friction on physical materials, it applies to movement component. When you are moving on any surface, it's actually multiplying your acceleration by friction coefficient of your movement component and friction coefficient of the material you are moving on. And it has a friction coefficient and friction static value is being added or lowered. So for example, if we want to make ice, we would make friction coefficient that would be a lot slower, a lot smaller. Okay, bounciness of the surface, restitution. So again, if it was rubber, we would increase it. If it was stone, like here, it's actually close to 0, or let's say 0.1, or actually close to 0, because stone is not very rubbery. So when you simulate an object that is made out of this material now and you drop it, and then it will just drop and it will just freeze in place instead of bounce around like a crazy ball. So this is also important. Density, density basically means that each object has certain volume, and when you simulate physics and you don't override the mass in kilograms, then it will take this volume and multiply it by density and then specify its mass in kilograms. So if we have a material that has physics material set up, it will actually take on toggling this, it would take and recalculate the mass in kilograms. So if that would be made out of water, then 1 cubic meter should be 100 kilograms, but if it's made out of stone, that's actually pretty accurate. Okay, velocity threshold. Okay, so this is for, again, physics simulation. Raise mass to power is larger. Okay, so if you scale object, it might not gain all the mass increase as it should, or it can even get more than that. Destructible damage threshold scale. So based on physics materials, destructible objects, but I don't know if it works with the new chaos physics, but for the old Apex destructibles, the physical materials would decrease or increase damage. So if we do 0.5, an object made out of stone would take only half of damage that a normal destructible object would get. And surface type is just surface type. So whenever you hit an object and you have a hit event, you have a physical material, and each physical material has surface type. And on surface type, you can do a switch, you can do a select, you can do a lot of different selector operations, and you can switch behavior based on the surface type. This is one of the easiest way to also share one surface between multiple objects. So we already talked about what physical materials do. Okay, and then we have replication. So, I would only not mark this one, and you can see that easy ballistic bullets are not even replicated at all. They are just not replicated. So the way that easy ballistic works is that it's doing a predictive bullet tracing on owning client and then comparing it to bullet tracing on server, but it's spawning projectiles that are just completely cosmetic on all clients that are non-replicated, and this way it's actually saving a lot of resources on updates of the movement of those projectiles, because when you have hundreds of projectiles moving, that could just kill your network, or it would make you skip few frames on those movements and you would have a bad time. But what this is doing is just replicating the spawn of the projectile, and it makes all the clients see the projectile spawned at the pretty much the same time, but not exactly, at the exact same trajectory and velocity of bullets. And there is a very small chance that you could see those bullets hit a different object on one client than another. For our weapon, we can immediately go into replication and say that it is not net load on client, but it is replicated. Okay, net use owner relevancy, yes, and we don't need to replicate movement, we don't need it to be always relevant, and we don't need it to be relevant only to the owner. That's it. So this gun is replicated already, this bullet has everything set up, and on impact we're not doing anything right now, so this is just a bullet that simulates what it should simulate, but it's not doing much. Okay, so let's go back here into class settings of just this barrel. We have this, we already discussed this, and now we can set up our ammo, and we can set up to BP test projectile. So this is the ammo that we set up, and now there are two ways to count ammo in the magazine. You see that this ammo type is an array. So right now, if we have cycle ammo, that means it will take the 0 index from the array, so the first bullet. If we add another bullet, like this one, or we can add actually multiple of the same bullets, what it will do, it will just take this bullet. Oh no, if we do cycle ammo, it will go one bullet after another, and it will just go through those classes, and then it will cycle until we reach max of our magazine, and our magazine count is, let's say, 30, and our position is 0, so it's the first bullet. So why we would want to set it like this? For example, in War Thunder, planes have ammunition belts. So some belts have, for example, armor piercing, 1 tracer, and 2 high explosive bullets. And what you would do, you would have a magazine round of, let's say, 1,200 bullets for your weapon, and it would have this tracer, AP, normal, and it would just go cycling through those bullets when shooting all over again. So this is especially useful for vehicles, but we're not using it like that, and we don't even need those entries. So you just leave one bullet, so it will constantly cycle through only this one bullet, and we want to have 30 bullets in magazine, and we don't want to change this by hand. However, if we don't do cycle ammo, this will be completely unimportant. This will be unimportant, and the actual magazine of the gun is this. So if we add 2 more entries, that means that our magazine got 3 bullets. And once we do a shooting event, one of those bullets, the first one in the array, will be removed from the array because it got fired, and when it's empty, it can no longer fire. So this is for a more complex weapon when you want to be able to construct your magazine yourself and pick what kind of ammunition in what order you want to input in those weapons. But we don't want that in here, so we would cycle ammo. Unlimited means that we don't need to reload. It will discount this, and even if we go to 0, it will continue firing. So we want to be able to run out of bullets. So yeah. Replicate variables, shot fired events, yes. Client-side aiming. That means that it is taking the client aim, not the server aim. And if we don't replicate our aim offset fast enough, we need to allow client-side aim. However, those weapons, they don't have a fixed spread that goes on some curves. So you cannot do aimbot like you do in Counter-Strike or other games where the spread is absolutely predictable. Because it's always on the same pattern in the same way, and you can counter this pattern by pre-recorded, cursor movements. Here you have random spread, so it's a lot harder to do auto aim, but that would still allow aimbot on client side. That will be a lot easier to do in script. But let's leave it as it is. Client aim update frequency 30 is more than enough. Aim distance limit. That means that if the client got very poor latency and he is moving, how far he can move on server side from the shooting location for it to still register shooting. Now, we are not a tank, we are not a car, and we are not a plane. So 200 units, 2 meters in network update latency, that would mean that our character is moving extremely fast. So let's lower this value. Let's say that it is maximum acceptance of 30 units, so 30 centimeters. 1/3 of a meter. Okay. And then we have some event dispatchers that we will use in a moment. But first of all, let's now use this gun and let's quickly showcase what it does. So now we don't need this gun, we don't need this arrow. We know that this gun got certain location and rotation. Okay, so let's copy this. Let's go into our mesh and let's go into skeletal mesh and let's go into our right hand. Okay. And we'll add a socket, which will be, come on, example gun socket, and this socket will have this location and it will have this rotation, so -90. Okay, so now oh no, I need to point the gun. This is the rotation. Copy, so 2076. Okay, paste 2076, and now I can delete this gun at all and this arrow as well. Okay, so let's go into event graph. Now we need to spawn a weapon and attach it to our character. Now we shouldn't do it as begin play. This is just for example purposes. Normally you should have inventory handler that would spawn, despawn, and save relation between the character and the weapon itself, but let's just do it in here. Spawn actor from class. Now, this is now this is a replicated actor, so we want to spawn it only on the server. If we would do it on begin play and spawn it on server and on client all the same, if we test this project in multiplayer, we would have two copies of the weapon. The one that was spawned on the client, on the server, and it would replicate down to client, and then a second one would be spawned only on the client, and even though it's replicated, because it was spawned on the client, it would be irrelevant to anyone else. And the last one that got spawned, so the client side one, would get the saved reference, and yeah, that would complicate stuff a lot. So let's do it like this. Okay, example gun, owner, instigator, self, and self. We need to set owner because owner is being ignored by the barrel, so that's very important. We are the owner of it. Spawn transformed, so get actor transform. And we got the class, and now we can, well, first of all, save the reference. So weapon reference. If we want to do anything with this specific weapon, we need to have a reference to it. And now we need to attach to component. And we are attaching to mesh, obviously. And the socket name is that new socket that we created, which is example gun socket. Okay. And because we got it, then we can snap keep world, and don't weld simulated bodies. We don't need that. And that should be it. Okay, but because we are only doing it on server, this reference, it has to be replicated. Okay, now it will replicate down to client. So now on client side, we can go into input, and when we have, okay, this is this input. Do we do anything with mouse buttons here? No, we don't. Okay, so let's do it. Okay, maybe here. Maybe without a space. Okay, weapon example. Right mouse button and left mouse button. And R key for reloading, that will be necessary as well. Okay, so first of all, let's take the left mouse button. Let's forget about those two for now. So what we want to do on left mouse button, we want to get our weapon reference. And we don't need to check all those weapon ready or anything that we already set up for this blueprint, because it will not fire if it's not allowed to fire. So weapon reference get, and there is an event which is called oh my god, what is it called? Let's see. Oh no, okay, so weapon reference, this weapon has we already know that this weapon reference is BP example gun, so we can get EB barrel, and we can get the component itself, and from the component we can get shoot. Okay, so when we are pressing, we are shooting, and when we are releasing, we are letting go of the trigger, and that's it. Here. Okay, so let's see, what do we expect. We expect that once we attach this weapon, we can immediately start shooting until we run out of bullets, which is 30. And Where is it? Shooting blocked. Okay, so shooting is not blocked. We are in full auto mode. We shoot 5 times per second. We got 30 bullets. And yeah, let's see how that works out for us. So let's start. We spawn. We got this weapon. Weapon gets attached. Okay. And when I press left mouse button, I shoot. Oh, the spread is really big. Okay, so I'm shooting, even though I am not aiming. If I go into C, so I am now first person, I am shooting again, but the spread is idiotic. Okay, so let's go back into our spread. I think I misunderstood something. Okay, so this is number of units per unit, so 1 per 1 is terrible. So this should be 0.001 even. Okay, let's try it now. Okay, it's mostly shooting straight, but it's not exactly in one single point, and it is actually aiming as we are swaying with the weapon. Okay, let's make it smaller. Let's make it 100. Okay, and yeah. Okay, see. So even the animation, not only the random spread, but the animation itself also has an influence on the spread. And oh, nice, that was a ricochet, and we can ricochet from the ground a lot easier because we set it in the material that it's an easier ricochet, but it's also a more wild ricochet at wild angles. And we are out of bullets. So we know that it's working already, so let's do some adjustments. First of all, by default, we want it to be shooting blocked. And then we want to check when we are readying the weapon. Find reference. Okay, so we are readying the weapon here. And we want to do one more thing when we are readying the weapon. So we want to get weapon. EB barrel. And then set shooting blocked. So weapon not ready, shooting block. Weapon ready, shooting unlocked. Okay. Oh, okay. And this, simple as that. Let's see. Okay, we can't shoot. We can shoot now. We still can shoot. And we can shoot now. Okay, so that works. Okay, but we want to also get some feedback from the weapon, like how much bullets we got left, how much, anything, whatever is happening with the weapon itself. So let's go into our example gun, and let's right click on our barrel, and now we have some event dispatchers that exist on every actor component, but some that exist only here. So let's go into shoot fired, shot fired, ammo depleted. That's a new one. Ready to shoot. And I think that's everything that is this class related. Let's see, anything else? No, okay. So we got those three. So ready to shoot is an event that's being shot right before we actually spawn the projectile. This is on the same frame, but before spawning the projectile. Shot fired is an event that triggers also on the same frame, but after spawning the projectile. So we want to do some stuff here first. So let's do a print string, and we want to do, you know what, print text. And we want to format text. I want to say ammo 0 by 1, And well, we know that the max is 30, but we might change that if we want to. So magazine size. Let's make a magazine size. It's an integer and it is replicated and it spawns and it's being set on spawn and the default is 30. Okay, set, save. Let's go into our example character and where we are spawning the weapon. Now we have magazine size of 30 and we'll leave it at 30, but we can change it to any other value or we can change it at runtime. And now we'll make it replicated with notification. And on magazine size changed, we'll get the barrel and we'll set cycle ammo count. So it's not changing the position. The position is how many bullets already were shot from the magazine, but this is the ammo count of the weapon itself. Okay, so what we are doing, we are setting our value on this weapon to the barrel value, and that's it. And also event graph on begin play, we have to do the same again. So we need to just go here and just copy this and just do it here. Okay. So now we can do a print text by 0 by 1. So we will get our barrel. Get cycle ammo position, and we can get cycle ammo count. So this is where we are on how many bullets in total. Print that after every shot. Okay, so that's our first small thing. Let's play. And now position 1. Okay, because we're not cycling ammunition, it will always say that 1. But it will tell us how many bullets we have left. So we'll change that real fast. Ammo count will be here, but our magazine size is here. And now, after each shot fired, we will know how much ammo we have. And if we on spawn change this 30 to, let's say, 40, because we have extended magazine, we now got 38, 37, 36 on 40. Okay, that's amazing. So instead of printing text, obviously what we would do, we would get player controller HUD and just do stuff on the HUD. Or inside the HUD, we would get player pawn, and then we would use an interface call to get the weapon reference. From weapon reference, I will show it here anyway, really. So if we have our reference to our class, we can get our barrel, and from that barrel we can bind event fired. So we can make an event that is fired. So inside the UI, instead of binding some display value of ammunition and make it tick every frame to read this value from certain component, we can bind an event, and that would do a custom event that we will call update ammo count. And now this event would be called only when this value is being, when this event is being called on this component of this actor. So this is how we would update UI. Okay, and I think I will even show you an example in future of how to do that on an actual project that I am currently developing for someone. So let's go back here. This is just a very fast example. After shot fired, and now after shot was successfully fired, because this deploys only when, oh well, both deploys only when it can fire. We can do sound, you know, muzzle flash, light effects, you know, spawn casing, do spawn animation for the weapon. And also, when every shot is being fired, we can play animation of us shooting here inside the character directly, and we don't need to we don't have to play montage here. We don't have to do that at all, because we can take this barrel and we can bind event shot fired, and bam, we can do an event here and play a animation here. So it will play only when we fired, not when we pressed mouse button. So we don't have to do some elaborate tricks of did we actually fire, did our trigger actually fire a bullet? Well, we know it from the event dispatcher. Okay, ammo depleted, print text, no ammo. Okay, and that's it. Oh, that's interesting. Huh. So when this is being called, let's cancel that. Let's go into override. Does it have any description whatsoever? No. That's interesting. Okay, I never used this event. This is a new event, so I don't really follow why it even exists. Ammo depleted. Huh. Okay, never mind. Ready to shoot. We'll do one thing here on ready to shoot. So we'll get owner. From our owner, we will get camera, get active camera message. So we already implement interface that allow us to call this message. So we get the camera, we check if it's a cine camera or standard camera, but we know it's a standard camera. And okay, AGR, and we'll do a forward trace of this camera, or we can even do a select. So option 1, option 2, standard, true. Okay, so true goes here, false goes here. Okay, it's like this. By visibility channel, object types make static, dynamic, pound, physics, actually everything. Trace complex. Okay, we don't even need this channel types because we're using this object types, because if we mark this as false, then we're using object. If we mark it as yes, we're using channel. So it will be visibility channel complex 5,000 units. Actors to ignore, we'll make array, and we'll ignore obviously self, so the weapon itself, and weapons owner, which is the character. So we're ignoring those two. And we don't have to ignore self because we are ignoring self anyway. But you know what? It never hurts, because I don't know if this is not the context, so self would be the camera actually. Draw debug type none, we don't need trace draws, and if we got a hit, split structure pin, and we got okay, so if not, we want to vector trace end, and if it is true, we want to get the hit. So what we want to do, we want to take this barrel, set rotation, okay, and want to find, look at rotation, from weapon mesh, socket, and the socket name is muzzle, and the target is select. Select is depending on hit. So if we do have a hit, so it's a true, we want hit location, but we want actually impact impact point. And if it's false, so we didn't hit anything, we want trace end. Okay, so now the barrel is rotating toward the crosshair. So it is ignoring our actual barrel aim. It's just cheating by few degrees. It's not, you see, it's not that bad, but it is cheating. So it's actually aiming at our crosshair. So now we are, if we are aiming at something that is closer to us, it will hit the crosshair. If it's far away, it will still aim at the crosshair. Okay, so we know that this is working, but running this on tick on every frame would be very excessive. As long as shooting blocked, so as long as shooting is not blocked, we will adjust the barrel position, and we will double adjust the barrel position when we are ready to shot. And now, no matter how much we sway our weapon, if we go into first person, it will aim at our crosshair. Okay, and we got no more ammo. Okay, I'm back. Let's do one more thing. So now we have a weapon. This weapon, when it is ready, it will shoot at our crosshair. As you can see, I have a camera offset, but it's still aiming at the crosshair in this method. But only when the weapon is actually prepared. Right now it is not adjusting the aim. And even if I try to trigger, nothing will happen. No animations will play, no sound will play, nothing will happen because shooting is blocked. If I go here, I can shoot and I am depleting my ammunition. If I hold shoot, I will be continuously shooting with 5 shots per second. Okay, and let's maybe add something that could, let's make it here. And let's make it smaller, so x.1, y1, z2, and let's override its material to wood. Okay, so we made different settings for wood. This is not simulating physics, I hope. No, it's not. It now has a scaled mass of just 50 kilograms. We can save. And now when we hit play and we go into C, we are shooting at concrete, at stone, and we can ricochet at some angles and some lag. Oh, you can see there. And the bullets, they act really... Oh, okay. Another thing to fix. So if there is no hit, so false, that should work. So when we have hit, it goes here. Channel. Oh, okay. That's terrible. So we cannot use it like that. Okay, that's not a big of a problem. I will fix it later. Right now we'll do a very small fix. We'll just... Nah, we'll just ignore it for now. Or, you know what? Okay. and we will go here, make, and same here, make. And what we need right now is from this hit event to have trace start and trace end, and that's it. Start and stop, and same goes here, so it will be just, where is it? Okay, we'll just go start and stop, and we can hide the rest because we don't need it, hide the rest because we don't need it right now. Just put it here, put it here, compile, save, bam, library updated. Let's go back here, and we shouldn't have to change anything else. Let's see, I am aiming here. Yeah, okay, I am shooting at the great nothingness. And the bullets just go until they run out of velocity. And will they start falling down? I guess they will, but they are now just falling down by gravity, so it will take a long time, and they will not deal any actual damage because of the velocity. So let's go back here, and let's test our wooden board. So it should over-penetrate easily, and it is. And it is changing the angle of the penetration a bit. And on any line trace that got hit, I see that sometimes it is wider, sometimes not. And it can actually even penetrate and then bounce. So that's really cool. And we run out of bullets. So let's do something about this running out of bullets. So inside the character example, when we got this weapon example, we got left, and let's not use this right. Let's go R and do a reload, right? So in order to do a reload, all we have to do is get the weapon, get the barrel, and what's let's see, what's the class functions? CDE. So shooting got Gatling spoon, shoot switch fire mode. Okay, so switch fire mode could be useful as well. And oh, we'll do right mouse button, and we'll actually do switch fire mode. And if we are holding the mouse button, we'll go semi-auto, and if we let go, we'll go full auto again. So a very small thing here. And now on R, we want to also get this barrel component of our weapon. What we want to do is charge. Oh yeah, that was charge. No. Okay, so it's at ammo. Get ammo count. So get ammo is just getting array of current ammunition with chambers, so we can know exactly how many bullets we got, including the chamber bullet in our magazine. Other thing we can do with ammo is just straight at ammo count, so it's the same thing basically what I did. Set ammo, unload chamber. Okay, set ammo. Okay, set ammo. Set ammo is the reload event, and charge is for this bolt action that I said that requires extra action. So this extra action is charge. and this should be run only on client and is replicated to server. However, this function is already, like you can see with this computer and a lightning, it means that it is a protected function that can only execute on server, authority only. So this function being run on the client, it will do nothing. If we hit R for reload, it will not do anything. So we'll have to do something a bit more slick. So let's do it right now, and let's go into our examples, blueprints, interfaces, and we got our example interface. We'll add a function to example interface that will be called getWeapon, and it will just do an output of weapon, which is example weapon, example gun object reference, and that's it. So now we'll go into our character and we got our interfaces. Let's see, do we already implement example interface? No. So let's that example interface. Okay, we got example interface, and now in our example interface we have get weapon, and on get weapon we will just push weapon. That's it. And this is a replicated variable. So now we'll go into examples, animations, animation starter pack, and there should be a reload. Reload pistol, reload rifle hip, rifle iron sight. Okay, let's use this one. So reload rifle hip. Let's look at it. Okay, that's good enough. So let's make a montage out of it. Create any montage. And let's not change its name. We don't care, honestly. And this will be an upper body montage. Save, don't do anything else. Reopen, so it reloads. Okay. So we are here emptying the chamber, and here we are actually reloading. So we can do 2 notifications. Or you know what? We'll just do it with 1. It will be easier. Bam, here. So add notification, and we'll do. We could make a custom notification, honestly. Or we can. Okay, just play montage notify, and this will be a notify name. Or you know what? We'll do a custom one. It will be more proper. So let's go into our blueprints, here into weapon examples. You know what? We'll do a weapon examples. And we'll drop everything here into weapon examples, move. Okay, and here we'll do one more thing. We'll do a blueprint class that is an anim notification, anim notify. So select, it will be called BP reload. Okay, and on BP reload, we get override receive notify. From mesh component we get the owner. The owner is the actor itself, so get owner, and from this owner we will get weapon message, and we will get this weapon, and we'll say if it's valid, because if it is not valid or it doesn't implement the interface, then it just failed. But if it doesn't fail, what we want to do is take this weapon and say ammo, charge, no, not charge, but EB barrel, ammo, set ammo. Okay, so this is the reload. And here we should have another function that is here on the weapon. Okay, we'll make it. Why not? Let's call it just ammo. Let's expose it as well. And let's say that it is 120. So on begin play, the weapon is already loaded, which means that we are setting this cycle ammo count. So we are also taking our ammo and we are then making it smaller by this value, and we'll also set ammo. So 120 is the overall ammo that we have, so whatever we have in the magazine is already in the magazine. So that's it. We go into our examples, we go into weapon examples, no, into event graph, and here into weapon we can see 40, 120. So what we should have 40 bullets out of a magazine size of 40, and overall bullets in our backpack should be 80. So let's go into bullet again, I mean into gun, and here let's do it like this and say this. And this also should be replicated. No, just replicated. Okay. And okay, and that's it. And now let's see if it works. Oh, what's wrong with it? Failed to compile, BP reload, count. Oh, okay, make. We just got one bullet, so that will be easy. Normally we would read bullet class from here. Unload chambered, no. Cancel shooting, obviously. Manual charge, no. So that would require us to use the charge. And what we would do in, I don't know, the sniper reload, we would have, instead of notification, we would have a notification state. And at the start of the state, we would set ammo, and at the end of the state, we would do a charge. So that would be the difference. So it would be still a single animation, but it would have two events, one on the start of a notification, one at the end. Okay, so this stays like this, and now count. We will get ammo. And we'll get, what did we call it? Magazine size. And we'll have to do some very small calculations here. That shouldn't be a problem. So if our ammo is greater than magazine size, basically. So if we got more bullets than in our backpack than a full ammo, then we want to do weapon magazine size, a full load of our magazine size, and we want to set ammo, which is ammo minus magazine size. Okay, so we took 30, 40 or whatever bullets, and we loaded them into the gun itself. Okay, now no errors. And then we reduce this number of bullets from our magazine. But if we have less bullets, less ammo than our magazine size, what we'll do, we'll just load all the ammo into magazine size, and then we'll also return true. So we will do this and this again. However, and this is a barrel. Now, it's the same array. This stays the same, but the count is now ammo, because we're loading all of our ammo because it's less than magazine size. And then we're setting ammo on our weapon to nothing. Okay, that's it. So now we have a proper reload. Looks complex, but it's really not. And we go here and we will do our BP reload. Out notify BP reload, and that's it. Save. So what we need to do now is we go into our character and we'll do a reload, but we'll check few things. So we'll take our weapon and we'll check also what we have here. So if our weapon is ready, or actually not, if it's not ready, it doesn't matter for us as well. We can reload. Okay, so we have to check if ammo count chamber is smaller than our weapon reference magazine size. So if we already have same number of bullets or more, we don't want to reload. But if we don't, we want to reload. So if our ammo count, including chamber, is less than magazine size, you know what? If we allow chamber, then magazine size plus 1. And if it is true, then we want to play this reload animation. But we already have networked montages, so we'll do a play networked montage, and it will be reload. Rifle hip montage. Start section none, play rate 1. Okay, so now this montage will play on the client and it will be replicated to the server, and server will run this and server will set this, and server will also manage our ammunition. So everything is being done on the server side, but the triggering of this entire event and reload itself is being done on the client side immediately after we click the button. So this is reload. Okay. Don't crash. Play. Okay, so I'm trying to shoot, nothing. I'm reloading. I can reload because I didn't have a bullet in a chamber. Now I have a bullet in a chamber and a full mag. So I should have 41 bullets out of 40, and I should have 79 back in the backpack. So let's see about that. So if I shoot once, I should have 40 bullets and 79 in the backpack. So 40 out of 40, and spare is 40. Okay, that's strange. So we messed something up. Let's reload. Huh, something is messed up definitely. Okay, so let's take a look. And now we go back here to reload, and from this weapon we check if it's valid. If it's not valid, then we just return false and nothing happens. If it is valid, we can do some operations on it. So first of all, we read 3 of the most important variables, and then we do a first gate check. Gate check is checking if, first of all, we don't have a full magazine, so our ammo count with the chamber is not equal or higher than magazine size. If it's not, and also our spare ammunition in backpack is more than 0, so we can reload, then we go into true and can reload. If we can't, it just fails. If we can reload, now we need to know how many bullets can we reload. So we get the ammo count of the magazine, because when we are unloading magazine, we always lose 1 bullet at the chamber. So we do not count chamber because it stays inside. And then we deduct from this number the magazine size. And we have a negative number that says how many bullets we are missing inside our magazine. And this is this value. Now we check this absolute value if it is higher than the absolute value of our ammunition. If we miss less bullets than we have bullets, so it's true, we'll do a full reload. So we'll just reduce the number of bullets in backpack by this number that we have here. And then we'll set it as ammo, and then we do a full reload, cancel shooting, and just do an ammo count of our full magazine. And the easy ballistics takes care of the extra chamber bullet itself. Now, if this is false, so we don't have enough bullets to load a full magazine, we know that we want to load at least as many bullets as we had. So we get this value of EB barrel, and it goes here. Okay, so we know that we want to load, it goes here, so all of our ammunition that we have spare, all of those bullets, we'll count them as our spare bullets, and then we will just empty all our bullets. And on reload, we just load all of them inside, and that's it. So let's test it. And you know what? We even should have content, examples, audio. Yeah, we got a firing, so why not? Let's go into example gun and ready to shoot. No, shot fired. Shot fired. Play sound location. Location is the actor location. Get actor location. This is the location. Rotation is irrelevant. We'll set this first tempo. Okay. Start 0, pitch, volume, whatever. We'll set owner to our owner. Attenuation settings doesn't really matter. You know what? We'll just set it to none. And now we reload 70 to 40. Speed 41. Oh, okay. Wait, let's fix that. Let's go back into our example gun and let's do it differently. So this is this. Debug string print and then play sound. And this event is now just this event. Ammo count after shooting. Okay, so that should be it. Okay, F11. And see what will happen. Okay, so one more small adjustment and we got everything done correctly. So this plus this ammo count. Because this is the last reload. We take all the bullets that we already have and we add all the bullets that we have left. Okay, and now it's complete. And everything works as intended. Okay. So what else can we do? Oh, let's go back to our bullet now because we got weapon, and now If we want a new weapon, all we have to do is just go into examples, blueprints, weapon example, make a child of this, just create a child, and this will be BP fast gun, for example. So BP fast gun is of class BP example gun, and I can open it. I can go into class defaults. I can say magazine count 200, ammo count 1000, and I can access it components. I can go into this barrel, and I can say that the fire rate is 50, not 5. And just save it, and now I can go into our character, and when we spawn our weapon, nothing will break if I change it to fast gun. I can change this value back to 200 and 1000. Okay, compile, save, play, and now yeah, now this happens. And reload, and it should also reload properly. Yeah. It didn't hit performance as much as I thought when I'm shooting at this in idiotic way. That's surprising. Okay, let's go back to the bullet, and inside the bullet we got this event on impact, and here you can, for example, play sound of ricochets. You can spawn, you know, spawn decals and spawn particles, and you have location of the hit of this projectile, and you have also exit location. And you have normal. Normal is basically the rotation, and it is just inverted on the exit. So that's it. You have the impulse, which is a vector, and you can use it to apply damage. You have the actor that you get hit, and component and standard stuff that you got from hit, and a full hit event. So you can use this to do whatever you need to do, to apply damage, to apply effects, to apply other stuff. But I will cover that in the another tutorial, because this one is getting probably super boring and long. So I will just end up here. So right now we got a character that got a weapon. This weapon is unusable unless we unlock it. When we unlock it, it is automatically aiming no matter the IK system at the center of our screen. Has some random small adjustments, can not be as pinpoint precise. It can run out of bullets. We can reload it. It got a chamber mounted bullet, so it can have a bullet spare. Okay, and so this is how you use Easy Ballistics. It's multiplayer ready, so we can actually even test it. Okay, it looks the same. Okay, our mesh also, I forgot, it needs to change one setting. So in the update, in the skeletal mesh, optimization, yeah, here, always tick pulse and refresh bones, because we are attaching to a bone, so this is important. Second thing, we are this should be all okay. This should be okay. Okay, this should be okay. maybe I can even increase this, or frequency, we can do it 60 and distance 300 and see. So yeah, this is how we work with Easy Ballistics in general. It got so many options and it is a very accurate representation and simulation of projectiles. So enjoy this tutorial and thank you for listening, and if you want to stay tuned, please consider subscribing and liking the video, because I am trying to input as much tutorials as I can in the near future. Thanks and see you guys soon. Bye.